Welcome modelers of YouTube to my build of the Trumpeter 1 to 200 scale Titanic model. This is part 5 of my build series, and this video deals with how I solved my hull warpage and superstructure fit problems. Scott at the Aussie Trekkie YouTube channel just posted a good video illustrating the potential hull warpage and superstructure fit problems with this model. And many others have made similar comments ever since I started building this model back in April. So now I'm just an amateur model maker, and there are most likely superior ways of solving this hull warpage problem. So let me show you the idea I used to solve this problem. Okay, the first step that I did was to make these bulkheads. I made 4 for the middle part of the hull, and if you remember on part 3 where I showed the motors, I made 3 bulkheads to help support the propeller shaft housings as well as their motors. And to get the measurements, I first put in the C decks front and back. And with the C decks in place, this should be the proper width of the hull that would match the superstructure, hopefully. So I took measurements inside here with the calipers, both sides, and it basically came out with 5.056 inches. It was pretty even throughout. Here is what it should be. Then from there, the next step was to build part of the superstructure, and I just basically build the superstructure with B deck. So let me show you a little slideshow on how I did that. And remember that the slideshow, the volume is going to be a little bit less, so you may have to turn up the volume to compensate for the lower volume. So let's see the slideshow. After I glued and painted the superstructure wall halves, I laid the port side wall assembly on the work table. And as one can see when looking at the superstructure wall, it is not flat. So to keep the wall flush to the table, I needed to shim the wall in various places. I just used some index cards and pictures I had laying around. You will note that when you pre-fit B-deck to the superstructure wall, the superstructure wall needs to curve up from the table at each end so to stay up against the B-deck. So additional shimming needs to be done in a stair-stepping fashion to compensate for this curve. Once shimmed correctly so that the B-deck fit against the wall snug, I used some weights to hold the superstructure wall in place, so when I glued B-deck to the superstructure wall, the wall would not move on the table. Before gluing, all surfaces that would get glued were cleaned of paint. The glue I used was good old Tester's red tube model glue. I use this because it takes long enough to dry so that I would have enough time to apply the glue to this large part and make sure the B-deck sat at the right points on the superstructure wall before the glue set. Once the B-deck was set in place, I used a combination square to make sure B-deck was square to the superstructure wall. Now the B-deck walls made this process easier, so I would recommend completing the B-deck assembly in step 5 of the instructions before attaching the superstructure walls to B-deck. After the glue was dry, I did the same for the starboard side. And the result is B-deck with squared superstructure walls. Now that I had the superstructure started, I could take some measurements to make sure my homemade bulkheads were the right width so the hull would be straight, have additional strength, and match the width of the superstructure assembly. The next video segment will show how I went about taking those measurements. Just remember that I'm an amateur at making these videos, so the volume will probably go up with the video segments compared to the slideshow. And also note that these videos were made before the hull was painted. So first, notice some corrections I made to B deck. Okay, here is the superstructure partially completed. I have the superstructure walls attached to B deck. So first I finished B deck. I put all of the little walls in and then their windows. And I also put in the wood flooring that comes with one of the Ponto's accessory kits. And did some painting. Now in this kit there are some walls missing. The walls that go right here across here is missing. And this wall separates the private promenade space from the main entrance space. So there is a wall here with a door in it. There's also some windows missing in the front part of the ship. There is a square window missing right there. So that window had to be drilled out and squared. It's about 3 millimeters from the edge to the edge of the wall in scale. And it's just the same as these square windows here. So there's no frames, brass frames inside. And the other window that's missing is in the back at the second class smoking room area. The window on the side here is not included in the kit. So again, I had to drill out this side window, square it up, and since the Ponto's accessory kit has all kinds of windows that are extra in it, along with the windows that come with your kit, I just used one of those windows, and there's plenty, and they're just identical to these other windows that are along here as well. The other thing that I had to add too was a door that separates the cafe area. So this piece here is solid, that comes in the kit, so I just cut out the door and I put a brass door over top to make that more authentic. Probably won't really see much of it, but that just adds some realism to the kit. Alright, next let's turn this superstructure over and I'll show you the measurements I took. Okay, here we have the superstructure upside down. First thing I did was I taped on the sides of the superstructure walls some tape, and I put this tape also on the hull at the exact same spot. And then on the pieces of tape I put some marks. So we got a little mark there, mark there, mark there, and so on. And that also corresponds to a mark I put on the tape on the hull. And then from there I took some calipers and measured the outside diameter of these walls. And if you look closely here, if I can get it in focus, you have this little ledge here. This is where the superstructure will sit right on top of the hull. And then here's a lip that comes up, and that goes on the inside of the hull at the top. And so I measured from this side here, this lip, to the other side lip. And I arrived at these measurements. So up here it's 5.143 inches. This, I guess this area is beginning to bow slightly in to match the bow. And then we're getting near the center of the ship, 5.156 inches. And then a little back further near the rear grandstand staircase is 5.134 inches. And right front or back of the rear staircase is 5.146 inches. So that's how I arrived at these measurements. So let's take a look at the hull and see how I made this fit with the bulkheads. Okay, here we have the hull, and on the side of the hull I have some tape at the 4 places that match the 4 places I took measurements under the superstructure B deck. And on these pieces of tape I put a little mark so that I could get the exact measurement on the hull, the same location I took the measurement under the B deck. And these 3 bulkheads here, they originally measured 5.056 inches, and I arrived at that number based on putting the C deck in the back of the hull. That's part number W2, and then the C deck on the front part of the hull, which is part number W1. And that gave me a rough idea of what the width was. Now, originally I was just going to go with the actual measurement of the ship itself, and according to the records, the Titanic was 92 feet, 6 inches wide at its center hull here on the sides of the hull below the superstructure. And on the model that should be 141 millimeters. And as you can see here, I don't know if you can see, but it is only about 134 millimeters, and that's with all this matched up with the superstructure. So the width of the ship is not quite to scale, but I guess it's good enough. Well, once I got those measurements from the superstructure, I took the calipers, and at each corresponding piece of tape that matches the B superstructure, I put the calipers at that width, locked them in place, and then I took shims and I shimmed up the difference, because it seems like the bulkheads were a little bit too narrow. So at all the places that I had those measurements under the B deck, I put shims after I put the calipers in place. This one's just got a little skinny shim. And once that was done, glued everything in place like that. I took measurements. So this shim went from, or this bulkhead went from 5.056 inches to 5.068 inches. And this one went from 5.056 inches to 5.084 inches. And then this one in the front here was actually a little bit narrower. It was 5.045 inches, and it went to 5.057 inches. So that's what this hull measures at straight. It's pretty close to being straight now. If you look at it, it's got a little couple of wrinkles in it, but it is pretty close enough to the superstructure that it fits right in place now without any kind of problems fitting it in there. And that's how I arrived at this. Plus the bulkheads will shore up this hull. It makes it nice and firm now, so it's not so flimsy. And that's how I got the hull straightened. And that superstructure just sits right on top nice and lines up without a lot of effort. Okay, so now all the bulkheads are in, secured. The adjustments have been made to fit the measurements found on the superstructure. We got the C decks in. They're loosely in. This one fits nice and firm. This one has some play in it yet. So I took a clamp and I had test fitted it. So the clamp simulated this being tight as if it was glued, and the superstructure fit just fine. So basically this is how easy it fits. sits right on top. Everything looks pretty good. Move it over here. Let's take the camera off the tripod. And instead of a wavy hull, the hull looks pretty straight. Both sides. And that solved the fit problem that I had that was similar to Scott at the Aussie Trekkie channel. And that superstructure now sits on top of the hull with very little effort and lines up just right. So hopefully this idea helps. Any of you modelers out there want to try it. It does take some time to make those bulkheads, to get them shaped just right. I just started out with, I think it was just 0.040 thick clear sheets of plastic. Made the shape, and then once I found the shape that I needed for the bulkheads, then I added a sheet on the front and back, strips to add some rigidity and strength to those bulkheads so they wouldn't flex at all. And as a result, I have a nice solid hull, and it's squared up to the superstructure, and the superstructure goes right on top with minimum effort. So hopefully this helps. Until next video, have a great day.